Okay, we have another integral here today. This one's from Caltech Math Meet 2025, Finals 22. We have the integral 1 minus x over square root 8 minus 5x squared dx. Okay, I was really tempted to skip this one. I'm kind of tired of the Calc 2 kind of integrals. And it's kind of, I can see right off the bat that it's going to be a little bit of trouble just because we don't have nice coefficients here. So anyway, let's just do it. And what I want to do to start is we'll break it into two integrals, splitting it up on that minus sign. And then doing that, I think we have two pretty straightforward integrals. The one on the right can be done with a u substitution. Let's substitute for this right here. So I'll set u equal to 8 minus 5x squared. And then du is just going to be minus 10x dx. So to set it up, I want to create this. Let's bring the minus sign inside like that. I'll create the 10, and so I don't change it, I'll just multiply by 1 over 10 out there. So then let's just go ahead and do this one. So we end up with 1 over 10. The whole numerator becomes du, and we have square root of u, which all this stuff can be written as u to the minus 1/2. So when I integrate using power rule, that's going to be 1 over 10 there. This is going to become u 1/2, a 2 pops out, and so what we're left with is going to be 1 over 5 square root of u, plug back in, so it's going to be square root of 8 minus 5x squared. So let me capture this, and we'll deal with some labels. Let's call this first integral here, let's call it j, because our whole integral will be I guess. So then the solution on it's going to be whatever we find for j plus this thing, which I'll compact a little bit, 8 minus 5x squared over 5, and I suppose we can add a plus c for later. And let me just get some space and we'll continue on with this j integral. Okay, now for this integral here, what I thought I would do is generalize it, just because it's the same kind of situation whenever you have different constants on here. The simplest case, the real easy case is this right here. This integral is just arc sine, so this is the same thing as arc sine of x. And now here, I create the constants as squares just because we're inside the square root. I think it's going to work nicer that way. And when we do this, we're going to get something in this form, but we're going to have some a and b constants. So it's just a matter of where these constants are going to land and how it's going to look. You might already memorize this formula. I actually don't. I kind of forget this formula, so I'm going to derive it. But we'll start with this right here and we'll do some trig substitutions. Let me get rid of this. For the trig substitution, also we want to look at this right here. This is the same thing as bx all squared. So we'll do the substitution there, and we're going to want it to work with this a. So I'm going to want bx to be equal to a sine of t. Just because if you square this out and look at bx squared, this is going to be the same thing as a squared sine squared t, and that's going to work well with what we have there. Just because if you plug it back in and look at what we have, it's going to be a squared minus, when this becomes, after the substitution, when we have this, it's going to be something like that. But then you can factor out the a, bring it outside the square root, so we end up with a 1 minus sine squared t. This thing is cosine squared t, and so this is going to be just a cosine of t. I'm going to drop the absolute value because it's going to work out, but we'll have this thing. Now let me get a little space for the derivative. Now we're going to want to find our dx value. So if I divide off the b on both sides, we're going to have a over b here. Take a derivative, we get dx, a over b, cosine t dt. And one more thing, let's get a value for t, isolating it, rearranging it, divide off the a now. T is going to be the same thing as arcsine b over a of x. Okay, so I think we have everything we need. We'll come down here and substitute. So dx is going to be this, a over b cosine t dt. This thing, let's transform it all the way down to this. After we do all the cleanup and everything, we just get a cosine t, but then the cosines cancel, the a's cancel. Let's bring the b out front, so we just have 1 over b here. And all that's left is we're just integrating 1. So we do that really quick and we're going to get just t over b, back substitute with this thing. And so for this general solution, we just have arcsine b over a of x over b. And so now this thing here is going to be our j, but we need to remember what a and b were. So we're setting a squared equal to 8. So it's going to be a little messy because our a value is going to be square root of 8. And same kind of thing on the b value. B is going to be square root of 5. So let's see if I can put together a j value for this. Just plugging in our a and b into this, we're going to have arcsine of, we'll put together the square root, so we'll do it as square root of 5 over 8 of x over square root of 5. And all you do is take this and throw it back in and finish it off. Okay, so now all we have is the big display of watching me plug things in. So this goes here. So putting it all together, my final solution on this is just going to be arcsine square root of 5 over 8x over square root of 5 plus square root 8 minus 5 x squared over 5. Add a plus c, and that's it. So like I said, I didn't really feel like doing it, but once I jumped into it and generalizing it, it wasn't too bad. But yeah, I've probably done too many integral videos, especially ones like this. And after years and years of built up bitterness and resentment, sometimes you just want to move on to something else. So I don't know what to tell you. Okay, that's it for today. Thanks everyone for watching. Have a good day.